In this example, we want to put z-scores into action and really see how they work. So suppose the mean height of human males in the galaxy is 70.2 inches with a standard deviation of 2.99 inches. And the mean height of human females in the galaxy is 64.8 inches with a standard deviation of 2.79 inches. All right, Han Solo is 6 foot 1 inches, while Rey is 5 feet 8 inches. Who is absolutely taller? Okay, absolutely is not really a question. If you stand the two of them next to each other, Han Solo is taller. By 5 inches, right? Because she's 5 foot 8. There's 4 more inches to get to 6 feet, and then he's 1 more past that. So he is absolutely taller. No question about it. Absolutely is you put the two of them next to each other, right? However, it's not really fair to compare Han and Rey's heights directly because he is male and males tend to be taller. As we can see from the means up above. So, what are some other things that would not be fair to compare directly? All right, so let's just stick with the male female scenario for right now, just on a side note. So, let's think strength, so like upper body strength, that kind of thing, leg strength, shoe size, right? Men tend to have bigger feet, right? Pain tolerance. So they've actually done studies of pain tolerance, and it varies based on what type of pain it is. So men tend to be better at the stabbing type of pain, literally like if you're stabbed, and women tend to be better at the long-term agonizing type of pain. Fascinatingly enough, something like maybe having children, that kind of thing. Endurance, they've done studies on that as well. And so endurance changes. Actually, I could also talk about in dealing with pain, heart attack symptoms. They're actually very different. So, heart attack symptoms are very different for men and women, and they're just discovering that. A lot of traditional things that we've learned of for heart attacks are actually true for men, but not true for women, which is one of the reasons women are more likely to die of heart attacks if they get one. Right? Granted, men are more likely to have heart attacks in general, but women are often misdiagnosed. Their heart attacks are missed because they have different symptoms. Interesting, huh? And we could go on and on and on. I mean, there's a lot of things there. But let's think about some other things. I mean, as a student, what about the classic ACT versus SAT? All right, so the ACT is out of 36 points, and the SAT is out of 1,600 points. And I personally took both of them, and I had no idea how to compare my scores on the two of them. I had no idea. I don't know, which one's higher, which one's lower, right? Because they're out of two completely different scales. All right, what about my favorite? If you have plain M&Ms, right, the number of plain M&Ms versus the number of peanut M&Ms, right? Drove me crazy as a kid when I was out trick-or-treating, and there were so few peanut M&Ms in those bags, right? And it's because it's not really fair to compare them. They're different, right? They're based off of weight, actually, so that's why they can get away with it. But it drove me nuts. Like, there's 5 M&Ms in here, right? In other words, if you want to compare the weights of apples versus the weights of oranges, apples versus oranges, right? You would need z-scores to compare directly. All right, so in other words, to compare, to make relative comparisons. It's not fair to compare them direct, right? To compare them one versus the other. So to make that direct comparison, what you have to do is use a relative comparison. Compare each of them to their own group. How does this apple compare to all apples? How does this orange compare to all oranges? And then you can make that comparison. And z-scores are how we make it happen. Right? So it's not fair to, and so when I say who is absolutely taller, what I'm talking about here is a direct comparison. But we just said direct comparison was not fair, right? It's not fair to do that. So then how do I do a relative comparison? Well, that's where z-score will come in. The z-score will let us make a relative comparison. Speaking of which, let's find the z-scores, shall we? All right, so I'm going to go back up here to the top real quick. And I noticed that human males in the galaxy have a mean. So this is the mean for men is 70.2, and it's a mu. This is the whole galaxy. This is the whole population. And it has a standard deviation of 2.99. So that's sigma, which is 2.99. So it's the whole galaxy. So these are population values. It's not a sample, all right? All right, then for women, let me grab pink here to be all baby shower color about it. So for women, the mean is right here. So that's the mu for female, which is 64.8. And the standard deviation for female is right here, which is sigma for female, which is 2.79. Okay. All right, so why am I needing to note that? Well, because down here, when I want Han Solo's z-score, so the z for Han would be equal to his value minus the mean for all men divided by the standard deviation for all men. All right, so I need to know his height. I'll get there in a second. But I know that the mean is 70.2 and the standard deviation is 2.99. Now, I do have a slight problem, which is that I need to find his height. So they gave it to me as 6 feet 1 inches, but that's not useful for me. I need it just to be in inches. So let's note here, 6 times 12 plus 1 would be 73. So Han is 73 inches tall. All right, so he's going to be 73, take away 70.2 divided by 2.99. Which I will go grab a calculator right now and just do that and be done with it. So remember, you want to use either parentheses or you want to use alpha F1, number 1. 73 minus 70.2, and divided by 2.99. And there we get 0.936. All right, now what about for Ray? Well, we need to go back up here and figure out Ray's height. So she's 5 times 12 because there's 12 inches in a foot. So 5 times 12 plus 8, which is 68 inches tall. And now you can see where I got the 5 inches from, because 73 take away 68 is 5. See? Okay, so for Ray, the z-score is her value minus the mean for women, for females, divided by the sigma for females. So it'd be 68 take away 64.8 and divide it by 2.79. Okay, well, again, we're going to need a calculator to do that. So let's see here. I can hit alpha F1 again. 68 minus 64.8 divided by 2.79. And I get 1.147. So the question is, who is relatively taller? And the answer is Ray is. Her z-score is higher. So she's actually taller in relation to all women than Han is in relation to all men. So Ray is relatively taller, not absolutely taller. I mean, if you stand them up next to each other, he's taller than her by 5 inches, right? She's relatively taller because her z-score is higher. All right. Now, what about Kylo Ren, aka Ben Solo? Sorry, spoiler alert if you haven't seen the movies. All right, Kylo Ren has a z-score of 1.605. What is his height? Ooh, so this is going to be a tiny bit of algebra here, just a little bit. All right, Kylo Ren is male, so he's going to use this formula right here. All right, so let me write this down. So the z for Kylo will be equal to x minus the mu for men over the sigma for men, because he's male. Now, I know that his z-score is 1.605. They tell me so, right? So I know that this is 1.605 equals x is the thing I don't know. I don't know what his height is. But I know that the mean is 70.2 and the standard deviation was 2.99. Then I can solve this for x. How? Well, first thing you want to do is get rid of this division, because nobody likes a fraction, right? So you multiply both sides of the equation by 2.99. Because 2.99 divided by 2.99 goes away and just makes 1. All right, so we move that over. So let me grab the calculator. I need 2.99, oh calculator, times 1.605. There, and I get 4.7985. I'm going to write all of that. I don't want to round anything until I'm at the very end. All right. Now I want to add 70 because I'm trying to get the x by itself. I mean, this is what your goal is. Your goal is to find that x value, right? His height will be that x. All right, so I'm just going to add 70.2 to both sides. Whatever you do to one side of an equation, you have to do to the other. Negative 70.2 plus 70.2 disappears. And so I just need to add 70.2, and I know that he's 74.99895. So for all intents and purposes, he's 75 inches tall, right? So Kylo Ren is he's about 75 inches tall. I'm rounding that because it's so close, right? 74.9985. So he's 75 inches tall. Now, if you want to know what that is in terms of feet and inches, remember that you would have to divide it by 12 because there's 12 inches in a foot. So if you take 75 divided by 12, you're going to get 6 feet, right? And then 0.2499125 times 12 gets you inches. So he's about 6 feet 3 inches tall. In case you wanted to know. You could do it easier than that. 6 feet is 72 inches. So he's 72, he's 6 feet tall plus 3 inches extra. So he's 6 feet 3 inches tall. It didn't specifically ask for that. So we can just say it right here. He's 75 inches tall. But I thought it would be cute to know how many inches and feet that was because, you know, nobody walks around saying, I'm 75 inches tall. What they say is, I'm 6 feet 3 inches. All right, now Poe Dameron has a height of z-score of 0, which is actually true of the actor that plays Poe Dameron, or it is the character Poe Dameron, I can't remember. But they have a height z-score of 0. What does that mean? Well, that reveals that he is and that's, we go back, the mean for men is 70.2, so he is 70.2 inches tall. Right? Because that's the mean for men. So if you have a z-score of 0, it means you are at the average. All right, now let's go to the short side, shall we? But not the dark side, just the short side. So Princess Leia is 5 feet 1 inches tall, while her twin brother Luke is 5 feet 6 inches tall. Which one is relatively shorter? Well, I don't know, so we're going to have to find it out. So let's start with, actually, I'm just going to do Luke first, just because I've been doing the blue ones first. So let's find the z-score for Luke is his value. Oh, we need to find what that is. 5 times 6. Or excuse me, 5 times 12 plus 6. Sorry, I was making it 60 in my head. So 5 times 12 plus 6 means that Luke is 66 inches tall. Leia is 5 times 12 plus 1. So 5 times 12 plus 1, so she's 61 inches tall. So again, he's relatively taller. He's absolutely taller. She's absolutely shorter. So if you're looking for absolute, it's her, right? When they stand them up next to each other, she is shorter than him, right? But we're not necessarily looking for absolute. We're looking for relative. So relative, we're going to have to use the z-score. All right, so he is 66 inches tall minus the height of 70.2, 70.2 for men in the galaxy, and divided by 2.99. That would be his z-score. Her z-score, oh no, I've got Luke. They both start with L, of course they do, and Leia here. There we go. So she would be 61 minus, now the average for women was 64.8, 64.8, but they have a smaller standard deviation of only 2.79. Okay, let's see here. And that was the actual height of Carrie Fisher. As a matter of fact, I looked it up. Okay, so let's see here. I'm going to move this over here just so we can see it a little bit better. I'm going to do this one with parentheses just to give you some variety. So parentheses 66 minus 70.2, close parentheses, divided by 2.99. Enter. All right, so his z-score is negative 1.405, roughly. And just in case you don't own a calculator, if you're wanting to use StatCrunch, StatCrunch won't be great for something like this. It can be done a little bit, but it's tricky. I'd recommend just using Desmos, right? So for Carrie Fisher, for Leia, I apologize, it's 61 minus 64.8, dividing it by 2.79, like that. You can see it's negative 1.36. Or again, I could do parentheses 61 minus 64.8, close parentheses. Although once I hit the division bar, then it's going to make it a fraction. That's the beautiful thing about Desmos. So I can see it's negative 1.362. All right, so she's negative 1.362. So the question became, who was relatively shorter? She's absolutely shorter, but she's not relatively shorter. He is, because he's further to the left on the number line. If you think of your, here's 0 at the middle. She is at negative 1.36. So there's Leia. And he's at negative 1.405. He's further over. So this is the short side. This is the tall side, right? So Kylo Ren's way over here, right? Interesting, huh? Okay, so short is more negative, right? The more negative you are, the shorter you are. The more positive you are, the taller you are. So Kylo Ren, for example, had a high z-score of 1.605, I believe it was, right there. So that was Kylo. He's way over there. Luke is over here, and Leia's right here. So the shorter one is actually Luke. Not absolutely shorter, right? She's absolutely shorter. If you put them up next to each other, she's shorter than him by 5 inches, as a matter of fact. So, but Luke is relatively shorter because his z-score is more negative, right? It's a lower number. Remember, down here are low numbers, up here are high numbers. His z-score is lower. Right? It's farther to the left on the number line. When they're both negative, it can get a little confusing. All right, now, just remember, we've already learned this. So this is a reminder. We've already learned that if a data value is beyond 2 standard deviations away from the mean, particularly for a symmetric distribution, which this is most likely symmetric, then it is considered unusual. Okay, so very large values, so very tall people would have z-scores that are 2 or above. Well, let's just say above 2, so beyond 2. So if you're very tall, you would have a z-score that's greater than 2. If you're very short, you would have a z-score that's less than negative 2. So actually neither Luke nor Leia is unusually short, you'll notice, right? Because they're not lower than negative 2. Negative 2 would be over here somewhere. So maybe Yoda. Yoda would be unusually short. However, Yoda's not human, so we can't really use him as a comparison. All right, so another way to put that is the magnitude. The magnitude is the absolute value, so that's absolute value. And all we're saying is that the absolute value of that z-score has to be greater than 2. You have to be more than 2 away from the mean. That's what it's saying. The distance from the z-score to the mean, right? And that's z right there. Okay, so let's look at a picture. So in the middle, you have 0. What you want is for, right, here's 1, here's 2. Here's 0, 1, 2, and 3, and so on. It goes on. And then -1, -2, -3, and so on. So unusually tall values are over here. Unusually short values are over here. Or another way to say that is all of those values. Right? That's this one right here. Right? That says both of those things simultaneously. It says that the z-score, I swear that's a z, it got blobby. I'm sorry. That z-score is greater than 2. Means you're either greater than 2 this way or greater than 2 that way, away from the mean. So these are the tall values, the unusually large values over here. And these are the small values over here. All right, Captain Phasma is a female commander of the First Order's legions of stormtroopers. We're going to find her z-score. But I forgot to tell you her height. Her height is 6 feet 10 inches tall. She is 6 feet 6 inches tall. Amazing, isn't it? All right. So 6 feet 6 inches tall. She's getting there. So Z for Captain Phasma. I'm just going to put CP for Captain Phasma. I wouldn't want to offend her. She generally carries a big weapon. So it'll be her score minus the mean for all females divided by the standard deviation for all females. Okay, so I need to find her score, but I do know that the mean for all females was 64.8. The standard deviation was 2.79. And then 6 feet 6 inches tall. Let's see what that is. 6 times 12 plus 6. So that's 72 plus 6, that's 78. So she's 78 inches tall. All right. So again, I'll just grab the calculator. So parentheses 78 minus 64.8. Oh. I'm using the second insert key because it didn't like me. And then close parentheses, divide it by 2.79. And her z-score is 4.731, believe it or not. So she's really up there. So what does this reveal about her? She is very unusually tall. So Captain Phasma is very unusually tall. Because her z-score is well above 2. Anything above 2 is unusual, and her z-score is well above 2 at 4.7, so very unusually tall.